Hello, everybody. Today we'll be talking about section 10 2, chapter 10, section 2. This one deals with areas of trapezoids, rhombuses, and kites. And uh, one of these equations I'm pretty sure you guys have seen before. And the one with rhombuses and kites is actually pretty straightforward. But uh, just to note, for the rest of this chapter, you're going to need to uh, remember chapter 8, section 2, which deals with special triangles 30, 60, 90, and 45, 45, 90. So if you recall, for a 45, 45, 90 triangle, I'll try to draw this best I can. And remember, this is chapter 8, section 2. And we have a 45, 45, 45, 90. So this is 45 degrees. This is 45 degrees, and then this is 90. Uh, let's say this is side X. And since it's a 45, 45, 90, that means that both of these sides of the triangle are the same. And then the hypotenuse is going to be X times the square root of 2. So if you remember, for 45, 45, 90, the hypotenuse, which is the side that's opposite of the 90 degrees, is equal to X times the square root of 2. Then we have a 30, 60, 90. So we have a, and this is not to scale, so it looks the same. So 30, 60 degrees, and 90 degrees. Remember that 30 degrees is going to be my shorter leg, so it's going to be over here. This is going to be the shorter leg times the square root of 3. And this is going to be the shorter leg times 2. So there's two equations involved with the 30, 60, 90. So the hypotenuse is equal to the shorter leg times 2. And the longer leg is equal to the shorter leg times the square root of 3. 30, 60, 90, and 45, 45, 90 is going to pop up a lot in this chapter. So if you forgot how to do it, I recommend you go back to section 8.2 and refresh your memory on how to do these. But they will pop up a lot. Okay, so 10.2. They give you an area of a trapezoid. If you look over here, trapezoid is a quadrilateral. And it's a quadrilateral, if you recall from, I forget which chapter, but from earlier in the book. It's a quadrilateral where you have exactly only one pair of parallel sides. They don't have to be congruent, but they're parallel. And when you have a trapezoid, those parallel sides are called bases. So we have, and here they call the top one base 1, and here they call the bottom one base 2. And in between these two, so if I'll just do my best to draw the same thing. So we have a base 1, we have a base 2. So here's our base 1, here's our base 2. We have this line in the middle, this dashed line. And this dashed line is always perpendicular to both bases, meaning it's going to form a 90-degree angle with this base, and this line also forms a 90-degree angle with the other base. And this dashed line between both bases that's perpendicular to both bases is called the height. So when we find the area of a trapezoid, the area of a trapezoid is going to be 1/2 the height times the sum of the bases. Notice that the sum of the bases are in parentheses. So base 1 and base 2 are in parentheses, meaning that you're going to add these two guys first because of PEMDAS. You can multiply the height divided by 2, and then you multiply these two together. And that is your area of a trapezoid. Remember that an area is the measurement of the stuff inside of a particular polygon, and it has units, and the units are squared. So it would be feet squared, inches squared, meters squared. Any unit squared is going to be your area. And that is the equation for an area of a trapezoid. And they call this theorem 10-2. Area of the trapezoid is 1/2 the height times the sum of the bases. They give us an example. We have this trapezoid over here. We have this number here, 309. Notice that it's perpendicular to both, which since it's perpendicular to this side, and these guys are parallel, that tells me these two are the bases. So we use that same equation, which means that 309 is the height. So we have our 1/2, we have our 309, which is our height, and then we add the bases together, and then you multiply. So for the got it number 1, they ask you what is the area of a trapezoid with the height 7 centimeters, base 12, and 15. So before you do anything, I would recommend you write your equation first. So 1/2 the height times the sum of the bases, and that's going to be our area of the trapezoid. So in this case, we have a height of 7 centimeters. We have a base 1 of 12 centimeters. And we have a base 2 of 15 centimeters. So in this case, our area is going to be 1/2 7 times 12 plus 15. So 12 plus 15 which gives me 1/2 of 189, which equals 94.5 centimeters. Remember, our units are going to be squared, so centimeters squared, and that's our area. Okay, so that's that's a trapezoid. So, like I said before, the 30, 60, 90 is going to pop up a lot. So they give us an example, for example, number 2, where they give me this trapezoid, and they want us to find the area, but in order to find the area, first I need to find the height. So just to start off, we just write our equation for area of a trapezoid. So we have this trapezoid. And they're in meters. This is 2, and this is 5. This guy is perpendicular to both of them, so that tells me that this is the height, and they tell me that this is 60 degrees. So once I see that 60, that's automatic. Okay, this is going to be a 60, 90, and then this would make this 30. So remember that anything opposite of the smaller angle on a triangle is the smaller side. So this is or in this case, since this is 30, this 2 centimeters here is the shorter side, which makes this H the longer side or the longer leg. So this would be the shorter leg, this would be the longer leg, which would make this the hypotenuse. Since 2 is the shorter leg, I know that H in this case is going to be also equal to the longer leg, which means that the longer leg is equal to 2 times the square root of 3. So in this case, H is equal to 2 times the square root of 3. We look back to our equation and we know that area equals 1/2 the sum of the bases. So this is going to be 1/2. Notice that we have this 2 here and a 5 here. We're going to add these two bases together, which makes it 7. So it's going to be 1/2 2 times the square root of 3 times 5 plus 7. So 7 plus 5, those are my two bases, which is 1/2 times 24 times the square root of 3. 1/2 of 24 is 12. So our answer is going to be 12 times the square root of 3. Remember, we got to say our units, and our units are always squared. So 12 times the square root of 3 meters squared. Now, they ask you in your problems to keep it in the form of a radical, most likely. So if you see a square root, like you're going to see with the 30, 60, 90, or with the 45, 45, 90 triangles, you're going to see them specifically ask you to keep it in the form of a square root. Otherwise, they'll tell you to put it in decimal form. So keep that in mind. Problem number 2, they ask, or practice problem number 2, they tell you to look back at this same problem, but instead of it being a 30, 60, 90, they ask you, well, what if it's a 45, 45, 90? So if I was to draw this same thing again, same exact scenario. So area equals 1/2 height times the sum of the bases. Same trapezoid. Everything is the same. The only thing that changes is that this is now 45, which will also make this 45 degrees. This is still 5. This is still 2. This is still 5. So this is 90 degrees. This is our height. Since it's a 45, 45, 90, and this leg is 2, that means that this leg is also going to be 2. Because in the 45, 45, 90, both legs are the same. And remember that the hypotenuse would have been 2 times the square root of 2 for 45, 45, 90. So when I do the equation, it's going to be 1/2 2 times 7 plus 5, which would have been 1/2 of 24, which would have given me an area of 12 meters squared. So if it was a 45, 45, 90, the answer would have been 12 meters squared. Okay. Rhombuses and kites have the same equation. So we have a rhombus. It has a diagonal, and here in blue they call this diagonal 1. Has another diagonal here in red, they call that diagonal 2. We also have a kite that has a diagonal 1 here in blue and a diagonal 2 here in 3. I can recreate that. So we have a rhombus. And remember, a rhombus is a parallelogram, four-sided quadrilateral, in which all the sides are the same. That's a rhombus. So we have this one diagonal. They call it diagonal 1. They also have another diagonal. They call it diagonal 2. And the equation for the area of a rhombus is equal to 1/2 diagonal 1 times diagonal 2. That is a rhombus. It is also the same exact equation for diagonal of a kite. So we have a kite, and if you remember, a kite is a quadrilateral where the congruent sides are the consecutive sides are congruent, so no opposite sides are congruent. We have diagonal number 1 going down. That's horrible. We call that diagonal number 1. We have diagonal number 2 cutting across this way. And we say that our area is 1/2 diagonal 1 times diagonal 2. Identical equations. And they apply to both rhombuses and kites. They call this theorem number 10.5. Area of the rhombus and a kite is half the product of the lengths of its diagonals. So the example that they give here is that of a kite. So we have a kite which has this diagonal and this diagonal. They say that this guy is 2 centimeters. This guy is 3 centimeters. Oops, that is not 3 centimeters. That is 5 centimeters. This guy is 3 centimeters. And this guy is 3 centimeters. So, our equation is area is 1/2 the products of the diagonals. In this case, we're going to add them. So 2 and 5, we would add. So area would be 1/2 2 plus 5, which is diagonal number 1. So diagonal number 1 is 2 plus 5. And then diagonal 2 actually, I was being consistent with my color coding. Let's be consistent with color coding. Diagonal 1 is 2 plus 5. And diagonal 2 is 3 plus 3. So this would be 1/2 7 times 6 be 1/2 of 42, which equals 24, and this is centimeters squared. So our area would be 24 centimeters squared. Oops, 21. My math is really off. So 1/2 of 42 equals 21 centimeters squared. My bad. Okay. They asked what if for the area of a kite with diagonals 12 and 9. So they give me the diagonals. So I know area is 1/2 diagonal 1 times diagonal 2. They say that diagonal 1 is 12. They say that diagonal 2 is 9. So area equals 1/2 12 times 9, which equals 1/2 of 108, which equals 54. Remember that our units is squared, so 54 centimeters squared. All right, let's go through a couple more examples, and then we'll be done with this section. So they gave us a trapezoid for number 1. We have a 4 here, we have a 10 here, and we have a 6 here. So they rate that that's perpendicular. We have a 4 here and a, whoops, this is supposed to be 6. We have a 4 here and a 10 here. Remember that area of a trapezoid is 1/2 the height times the sum of the bases. In this case, the height is always perpendicular to both the bases, so it's perpendicular to both of these guys. So my height is 6. My base 1, we'll just call it 4. And our base 2 is 10. So when I do the area is going to be 1/2 6 times 4 plus 10, which is 3 times 14, which is 42 meters squared. 42 meters squared. Okay. Number 2, we have a trapezoid, looks like an isosceles trapezoid. We have this dashed line in the middle. Remember, it's perpendicular to both. They say that it's 18. Top one is 15, bottom one is 27. So area equals 1/2 the height times the sum of the bases. In this case, my height is 18. We'll call base 1 15. We'll call base 2 27. So area is going to be equal to 1/2 of 18 times 15 plus 27, which is 9 times 42. Which is equal to 378 inches squared. And that would be our area. For number 3, they give us a rhombus. They say that this is 3. They say that this is 5. So remember with rhombuses, if the diagonals are perpendicular bisectors of each other, so that means that they cut each other in half. So congruent perpendicular bisector. So if this is 5, then this is 5. If that's 3, then this is also 3. So we can call the red diagonal 1. That's going to be equal to 3 plus 3, which is 6. And then we have diagonal 2, which is 5 plus 5, which equals 10. And our equation for area of a rhombus is 1/2 d1 times d2. So in this case, it's going to be 6 times 10, which is equal to 1/2 of 60, which equals 30, and it's going to be inches squared. Remember that your units are always squared. They give us another rhombus. Oh lordy. In this case, they say that this is 12. So if this is 12, then this is also 12. Then they give us this as being 12 as well, which means we're dealing with a particular type of rhombus, which is a special rhombus, which is a square. This is probably a square. So the first diagonal is going to be 12 plus 12, which equals 24. The second diagonal is also 12 plus 12, which also equals 24. So our area is going to be uh, 24, oops, sorry, 1/2 of 24 times 24, which equals 576 divided by 2, and I get that the area is 288, and it's going to be 288 inches squared. Okay. Area of a kite is the same thing. So for number 5, here's my kite. They say that this is 10, this is 10, this is 10, this is 20. So the first diagonal is 10 plus 10, which equals 20. The second diagonal is 10 plus 20, which equals 30. So remember that area is equal to 1/2 diagonal 1 times diagonal 2. So in this case, it's going to be 1/2 20 times 30. Which is 1/2 of 600, which equals 300 meters squared. For the last one, we have also a kite. This is 3, this is 1, this is 2, this is 2. So diagonal 1 is 3 plus 1, which is 4. Diagonal 2 is 2 plus 2, which also equals 4. And remember, area is equal to 1/2 diagonal 1 times diagonal number 2. So area is going to equal 1/2 of 4 times 4, which is 1/2 of 16, which is 8 centimeters squared. All right, so there you have it. Those are your equations for trapezoid, kites, and rhombuses. So remember that for a trapezoid, your area is 1/2 the height times the sum of the bases. Your area of your kite is 1/2 diagonal 1 times diagonal 2, and then your area of your rhombus is also equal to 1 half diagonal 1 times diagonal 2. So those are your equations for chapter 10 section 2. Have a really excellent rest of your day, guys.